Hi guys, it's been a long time since we've had a video because of AP season, so I'm sorry about that. I promised a magnetism and currents video, but that never happened. Sorry about that again. But today's video is going to be on modern physics. So what is modern physics? Modern physics is basically just a branch of physics that's focused on the quantum scale. So this is when things are like super tiny. So this explains some inconsistencies or observed behaviors that aren't explained by regular physics. So first off, let's talk about the photoelectric effect. This is basically a phenomenon that happens when light shines onto a metal surface and electrons are ejected from the surface. This process is called photoemission, and the ejected electrons are called photoelectrons. Remember that, because I'm going to keep referring to them as photoelectrons. So let's go over some properties of the photoelectric effect. So these might be concepts that you see on multiple choice questions. So light intensity directly affects the amount of photoelectrons that are ejected from the surface. More light intensity means more photoelectrons. Similarly, frequency and energy also have a direct relationship. A higher frequency results in higher energy of those photoelectrons. The energy of each photoelectron solely depends on frequency. It has no relation with intensity. There's also a minimum frequency called the threshold frequency. And if the frequency is below this threshold, that means no electrons will be emitted. The minimum frequency will result in minimum energy, and minimum energy equals work function. The formula for work function is work function equals h, which is Planck's constant, which equals 6.63 times 10 to the negative 34th times threshold frequency. Now, another phenomenon is called wave-particle duality. This is a super interesting concept, and it's what made me like physics, so I recommend you guys look at this more in depth. But basically, this theory says that on the subatomic level, waves can act like particles, and particles can act like waves. And this is super weird because it would never happen on our scale. Like, imagine you throw a baseball, and it just starts diffracting. Like, that's literally what's happening on the quantum scale. So basically, you should know that a photon is pretty much just light. So it's supposed to act like a wave, but sometimes it acts like a particle, and we know this because the photoelectric effect proves that light can act as particles. Additionally, we know that electrons are elementary particles, right? But they can act like waves too. Electron diffraction experiments show that they can literally interfere and diffract just like waves do. So waves can act like particles, and particles can act like waves. Now here's an important formula that you need to know. This formula just determines the energy of a photon. So the formula is E, or E photon, whatever you want to write, equals Planck's constant, which is 6.63 times 10 to the negative 4th. It's Planck's constant times frequency. It can also be written as Planck's constant times speed of light in a vacuum divided by wavelength. Now, let's look at the Compton effect. So this is basically talking about the effect when an X-ray photon and an electron collide with each other. Basically, some of the energy from the photon transfers to the electron, so the photon has less energy, which results in a longer wavelength but lower frequency. So now the de Broglie wavelength is the wavelength which we associate with a particle in quantum mechanics. They might make you solve for this in a question, so the formula is wavelength equals h over mv, which also equals h over p. So remember, h is Planck's constant, m is mass, v is velocity, and p is momentum of a particle. Now on to atomic models. So if you guys have taken chemistry before, then these should be familiar to you. We're mainly focusing on the Bohr model and the current model, but let's briefly go over Rutherford just in case. So Rutherford's model was based off the gold foil experiment, where he shot a bunch of alpha particles which have a positive charge at a thin piece of gold foil, and most of the particles went right through, so he declared that most of the atom is made up of empty space. But there were small areas that deflected the alpha particles, so he concluded that most of the mass of an atom is centered at a positively charged space called the nucleus. He also believed that electrons orbit the nucleus. So following Rutherford was Bohr, who believed that electrons orbit the nucleus in fixed circular paths called energy levels or shells. He was partially right about this because this theory does apply to hydrogen, but it only really works for hydrogen, so it doesn't work for everything. He also figured out that electrons absorb or emit photons when they change energy levels, so props to him for that one. Now, the current model says that electrons are most likely located in these fuzzy clouds around the nucleus called orbitals. Also, electrons do not travel in fixed paths. Now, let's move on to energy levels. Let's focus more on this. So basically, electrons occupy these energy levels, which are fixed distances away from the nucleus of an atom. These energy levels have numbers. The ground state is 1, and all the numbers after that are excited states. Lower levels are more stable and have less energy, while higher levels are less stable but have more energies. So sometimes these electrons will transition between levels, and this will happen when they gain or emit a photon. Absorption is when an electron absorbs a photon, so it gains energy and moves up to a higher level. Emission is when an electron emits a photon, so it loses energy and moves down to a lower level. You can calculate this change in energy through the formula E photon equals initial energy minus final energy. Also, ionization is the energy needed for the electron to reach infinity. Okay, now you guys probably know the emission spectra by now. These are just the colors and stuff. So basically when an electron falls from a higher level to a lower level, and it shows as a bright series of lines of colors. Now we need to go over the 4 fundamental forces. So these are the basic forces of nature which govern how particles interact. I listed these in order of weakest to strongest. So the weakest force is gravitational force, which attracts objects with mass. Then we have weak nuclear force, which is most notably responsible for radioactive decay, and it converts neutrons to protons. Next up is electromagnetic force, which we talked about last video, so that's about charged particles and stuff. And then finally we have the strongest force, which is strong nuclear force, which binds protons and neutrons together to form the nucleus. Now, the standard model of particle physics is governed by those 4 fundamental forces, and essentially it explains how the basic building blocks of matter interact. So all matter is made up of these things called hadrons and leptons. Leptons are a fundamental particle, while hadrons are not. A fundamental particle is like the literal building block of the universe. Like, you cannot break it down into anything else. So a lepton is at its simplest form, while you can keep breaking a hadron down. So let's talk about leptons a little bit more in depth. Remember that a lepton is a fundamental particle. There are charged leptons, like electrons, and there are neutral leptons, like neutrinos. Leptons experience weak force interactions, and the reference table pretty much tells you all you need to know about leptons. Now, hadrons are not fundamental particles. They are subatomic particles made up of quarks. Quarks are a fundamental particle, though. So hadrons experience strong force interactions, and there are 2 types of hadrons. There are mesons and baryons. First, let's take a look at mesons. So this is a type of hadron that is made up of 1 quark and 1 antiquark. The quarks are bound together by strong nuclear force, so it's considered to be very unstable. Also, an antiquark is just a quark with the opposite charge. And this stuff is super easy because everything you need to know is on the reference table. Now, a baryon is the other type of hadron, and it's made up of 3 quarks, and protons and neutrons are considered to be baryons. Now, finally, we're on to quarks. So this is the smallest known unit of matter, and it is a fundamental particle, and it cannot be isolated. So quarks either come in the form of baryons or mesons. Another concept that you need to know is just mass defect and binding energy. So remember that a nucleus is made up of neutrons and protons that are binded together. So basically, sometimes the mass of the nucleus is going to be a little bit less than the mass of the protons and neutrons combined. That's a defect, though, because the mass of the nucleus is supposed to equal the mass of the protons plus neutrons. This happens because some of the energy gets released when they bind. So that missing mass is called mass defect, and they might make you solve for that in a question. Also, binding energy is the energy needed to bind the nucleus together, and this is the energy used in strong nuclear force. Finally, we have the iconic equation from Albert Einstein. So basically, Einstein said that mass and energy are equivalent, and their relationship can be represented by the equation E equals mc squared. And this is just a recap of all the formulas. So E photon equals hf, which equals hc over wavelength. E photon equals initial energy minus final energy. E equals mc squared. The Broglie's wavelength, so wavelength equals h over mv, or h over p. And then work function, so work function equals h times threshold frequency. Now let's move on to some multiple choice questions. Number 1. The diagram below represents a sequence of events, steps 1 through 10, resulting in the production of a D- meson and a D+ meson. An electron and a positron collide, step 1, annihilate each other, step 2, and become energy, step 3. This energy produces an anti-charm quark and a charm quark, step 4, which then split apart, steps 5 through 7. As they split, a down quark and an anti-down quark are formed, leading to the final production of a D- meson and a D+ meson, steps 8 through 10. Which statement best describes the changes that occur in this sequence of events? So this question seems hard, but it's just asking us about what's happening in the sequence. So in the first step, an electron and a positron collide. So that's matter colliding. Then after they collide, they become energy. So matter is converted into energy. Then after that, two quarks are produced. This question seems difficult, but it's actually really simple. It tells you right there that matter is being converted into energy, then back into matter. So this is choice A. Number 2, the threshold frequency in a photoelectric experiment is most closely related to the what? So remember that frequency is related to energy. They have a direct relationship with each other. So let's look at the answer choices and see if any of them relate to energy. So A is wrong because it's talking about light intensity, and remember that light intensity relates to the number of photoelectrons, not frequency. B is wrong because why are we talking about area? C is correct because it talks about work, and remember that work and energy are related. And also D is just wrong because where did thickness come from? Also, you can remember the equation work function equals H times threshold frequency. Threshold frequency, threshold frequency. There's a relation right there. Number 3, a photon of light traveling through space with a wavelength of 6 times 10 to the negative 7 meter has an energy of what? So this question gives us wavelength and we need to find the energy of the photon. To do this, we can always just look at our reference table, which gives us the equation E photon is equal to hc over wavelength, and then we just plug in to solve for energy. So h is Planck's constant, which is 6.63 times 10 to the negative 34. C is speed of light in a vacuum, which is 3 times 10 to the 8th. And then we divide that by wavelength, which they give us. So 6 times 10 to the negative 7. We solve that out. We're going to get answer choice C, 3.3 times 10 to the negative 19th joules. Number 4. The spectrum of visible light emitted during transitions in excited hydrogen atoms is composed of blue, green, red, and violet lines. What characteristic of light determines the amount of energy carried by a photon of that light? So super easy. This goes back to question 2. So it says here, energy. So what relates to energy? Frequency. It's always going to be energy and frequency, so we know the answer is B. Number 5. In the currently accepted model of the atom, a fuzzy cloud around a hydrogen nucleus is used to represent the what? So a fuzzy cloud is a part of the modern model being used for electrons. Let's immediately eliminate B because these models talk about electrons, not protons. And let's also eliminate C because water vapor is just stupid. Now, A is the correct answer because the modern model says that these clouds are where electrons most likely exist and they do not travel in fixed paths, which is why choice D is wrong. The model where electrons travel in fixed paths is the Bohr model. Number 6. Compared to a photon of red light, a photon of blue light has a what? So we need to take a look at the electromagnetic spectrum for this. So we can see that blue light has a higher frequency than red light. And once again, remember that higher frequency, I'm going to say F, higher F equals higher energy. So higher E. So we know that B is wrong and D is correct. Number 7. What is the charge on an anti-down quark? Remember that an anti-quark is just a quark with the opposite charge. So we just need to look at the reference table to figure out what the charge on a down quark is. So it says that a down quark is negative 1 over 3e. So we just take the opposite charge of that. So it's going to be positive 1 over 3e, which is answer choice D. Number 8. Which combination of quarks produces a neutral baryon? So remember, a baryon is a type of hadron that is made of 3 quarks. Basically, this question is telling us to look at the reference table and test out these different combinations to see which one gets us a charge of 0, because neutral means 0. So CTS is going to give us positive 3 over 3e, so that's wrong. DSB is going to give us negative 3 over 3e, which is also wrong, but UDS gives us 0. So that is the neutral baryon that we're looking for. Number 9, what total mass must be converted into energy to produce a gamma photon with an energy of 1.03 times 10 to the negative 13 joule? So we're talking about mass being converted into energy. So this is a dead giveaway to use the equation E equals mc squared, because Einstein said that mass and energy are equivalent. So we just do E equals mc squared and then solve for mass. So E 1.03 times 10 to the negative 13th joule is equal to mass times 3 times 10 to the 8th squared. And we solve for this and we're going to get D, 1.14 times 10 to the negative 30 kilograms. Number 10, an electron in a hydrogen atom drops from n equals 3 energy level to the n equals 2 energy level. The energy of the emitted photon is what? So this is super easy. All the information we need is on the reference table. So we just go in the reference table and look for the energy of hydrogen atom. So the energy at N3 is going to equal negative 1.51. And at N2, it's going to be negative 3.4. And so to solve for this change, we're just going to do E photon equals E initial minus EF. So it drops from 3 to 2, so negative 1.51 minus negative 3.4. Solve this, you're going to get 1.89 eV. 11. The momentum of a photon with a wavelength of 5.9 times 10 to the negative 7 meter is what? So we need to solve for momentum, and we're given wavelength, so we need to use the formula for de Broglie's wavelength. So H equals, wavelength equals h over p. And we're given wavelength, so 5.9 times 10 to the negative 7 is equal to h, Planck's constant, 6.63 times 10 to the negative 34 over p. And then when we solve this out, we're going to get a momentum of 1.1 times 10 to the negative 27. Number 12. The diagram below represents the hyperbolic path of an alpha particle as it passes very near the nucleus of a gold atom. The shape of the path is caused by the force between the what? So this diagram is literally just showing us Rutherford's gold foil experiment. Well, I spelled that wrong. Gold foil experiment. Remember that alpha particles have a positive charge, and the gold nucleus is also going to have a positive charge, which is why the alpha particles will deflect, because they both have positive charges. So that is choice A. 13. If a hydrogen atom is in the n equals 5 energy level, what is the minimum energy needed to ionize the atom? So remember that ionization is when it goes to infinity. So we just need to look at the reference table and then go to the hydrogen energy level diagram. So the N5 energy level is negative 0.54 eV, and ionization is infinity, which is 0. So in order to get there, the hydrogen atom needs to add a positive 0.54 eV. 14. Which of the following contains quarks? So based off these answer choices, we can just use elimination and common sense to figure out the answer is A, alpha particles, but let's go more into depth. So an alpha particle is made up of 2 protons and 2 neutrons, remember that, which is why it has a positive charge. Remember that protons and neutrons are considered to be baryons, which are made of 3 quarks. So basically, alpha particles are made of protons and neutrons, and protons and neutrons are made up of quarks, which is why alpha particles contain quarks. 15. The threshold frequency of a metal surface is in the violet light region. What type of radiation will cause photoelectrons to be emitted from the metal surface? So this question talks about violet light, so that's our hint to look at the electromagnetic spectrum on the reference table. Remember that threshold frequency is the minimum frequency for photo emission to occur. No electrons will be ejected under this frequency level. So the reference table tells us that violet light has a frequency of 7.69 times 10 to the 14th. So for photoelectrons to be emitted, we need to check for answer choices with the frequency which is higher than this. So when you go through all these answer choices, there's only one with a higher frequency than this. and that is going to be ultraviolet light. 16. A beam of monochromatic light incident on a metal surface causes the emission of photoelectrons. The length of time that the surface is illuminated by the beam is varied, but the intensity of the beam is kept constant. Which graph best represents the relationship between the total number of photoelectrons emitted and the length of time of illumination? So this tells us that light intensity stays constant, right? And remember that light intensity and photoelectrons have a direct relationship. If light intensity stays constant, then the number of photoelectrons being emitted will also stay constant. So there's going to be this certain amount of photoelectrons being emitted per unit of time. Now, since everything is constant, this number of photoelectrons being emitted will be emitted at a constant pace, So it's just going to end up being linear. So it's going to look like a linear graph, which is shown in choice D. 17. A hydrogen atom with an electron initially in the N2 level is excited further until the electron is in the N4 level. This energy level change occurs because the atom has what? So the hydrogen atom is going from energy level 2 to 4. So it's going up in level, which means it's gaining energy, which means it's absorbing a photon. So we know that C and D are wrong because it's saying it's emitting photons. So that's wrong. Now energy level 2 is equal to negative 3.4, while energy level 4 is equal to negative 0.85. So we have to do E photon is equal to EI minus EF. So negative 3.4 minus negative 0.85. It's absorbing a 2.55 eV photon. 18. A photon is emitted as the electron in a hydrogen atom drops from the n equals 5 energy level directly to the n equals 3 energy level. What is the energy of the emitted photon? So it's the same thing here. We just look at the reference table for these values and then plug it into the formula. E photon equals EI minus EF. So N5 is negative 0.54, and then N3 is negative 1.51. So plug that in, negative 0.54 minus negative 1.51. That is going to be B. 19. The diagram below represents the bright line spectra of 4 elements A, B, C, and D, and the spectrum of an unknown gaseous sample. Based on comparisons of these spectra, which 2 elements are found in the unknown sample? So this is really easy. You just look at the lines of each element and see which ones match with the lines of the unknown sample, and the ones that match are B and C. This one's really easy. So the answer is going to be choice B. Base your answers to questions 20 and 21 on the info below. Light of constant intensity strikes a metal surface. The frequency of the light is increased from 6 times 10 to the 14th cycles per second to 9 times 10 to the 14th cycles per second. Photoelectrons are emitted by the metal surface when the frequency reaches 8 times 10 to the 14th cycles per second. If the intensity of the incident light were increased while the frequency was kept constant, the maximum kinetic energy of the emitted photoelectrons would what? So light intensity is being increased, but we really don't care about that because only frequency affects energy. And since frequency is constant, that means kinetic energy will also be constant because they have a direct relationship. So it will remain the same. 21. The work function of the metal surface is approximately what? So remember, the formula for work function is work function equals Planck's constant times threshold frequency. So it tells us threshold frequency here. Photoelectrons are emitted when the frequency reaches 8 times 10 to the 14th cycles per second. That is our threshold frequency. So we just solve. So H is 6.63 times 10 to the negative 34. And our threshold frequency is 8 times 10 to the 14th. Solve for that, and we're going to get 5.3 times 10 to the negative 19th. 22. The diagram below represents alpha particle A approaching a gold nucleus. D is the distance between the path of the alpha particle and the path for a head-on collision. If D is decreased, the angle of deflection of the alpha particle would what? So remember that a gold nucleus is positively charged and an alpha particle is also positively charged. So two positive charges do not like each other, so they repel. This is kind of like a throwback to electrostatics, but as distance increases, that force of repulsion gets weaker. But here the distance decreases, so that force of repulsion gets stronger. So stronger force of repulsion means that the angle of deflection will also increase because the alpha particle is trying harder to kind of like swerve away from that nucleus. So the answer is going to be choice B. 23. Which graph best represents the relationship between photon energy and frequency? Remember that energy and frequency have a direct relationship, so as frequency increases, photon energy will also increase, and that is shown in graph D. 24. Base your answers to the following question on the data table and graph below. The data table lists the energy and corresponding frequency of 5 photons. The graph represents the relationship between the energy and the frequency of photons. The slope of the graph would be what? So this question is really easy. It's just asking us for slope, so we just take 2 random points. So I'm going to choose A and B. Wait, what? And E, sorry. And then energy is our Y and frequency is our X. Remember that slope is y2 minus y1 over x2 minus x1. And we literally just solve for slope. It's really easy. So since energy is our y, we're going to do 6.63 times 10 to the negative 26 minus 6.63 times 10 to the negative 15 over 1 times 10 to the 8th minus 1 times 10 to the 19th. Put that in your calculator and you're going to get 6.63 times 10 to the negative 34. 25. Base your answer to the following question on the diagram below, which shows a nuclear reactor designed to obtain energy in the form of heat from a nuclear fission reaction. What is the total energy produced by converting 1 kilogram of uranium to energy in the reactor? So this question is super easy. It looks harder than it is. It's just asking us for energy and it gives us mass. So obviously we should just put it into the equation, E equals mc squared. So E equals 1 kilogram times 3 times 10 to the 8th squared. Solve for that and you're going to get 9 times 10 to the 16th. 26. A photon of light carries what? So remember wave-particle duality. So photon is pretty much like a packet of light. So it has both wave and particle-like behaviors, meaning that it carries both energy and momentum. 27. When 2 times 10 to the negative 16 kilogram of matter is converted into energy, how much energy is released? Once again, the question is asking for us for energy, and it gives us mass, which is a dead giveaway to do E equals mc squared. So E equals 2 times 10 to the negative 16th times 3 times 10 to the 8th squared. Solve that out, and you're going to get 1.8 times 10 to the 1. 28. Base your answer to the following question on the diagrams below, which show a photon and an electron before and after their collision. Compared to the total momentum of the photon-electron system before the collision, the total momentum of the photon-electron system after the collision is what? So this is like a throwback to our unit on momentum. Remember that law of conservation of momentum says that momentum stays the same before and after a collision. So the answer is going to be C. 29. Compared to the mass and charge of a proton, an antiproton has what? So this is just like a quark and an antiquark. Anti means it's same mass, same everything, but now the charge is just opposite. So same thing here, same mass but opposite charge. So it's going to be choice C. 30. A helium neon laser emits energy in the visible red region in the form of what? So this question says that the laser is emitting energy in the form of visible red, so that hints us towards the electromagnetic spectrum, and that's kind of like light. And remember that photons are pretty much just packets of light, so our answer is going to be photons. Okay, so now let's move on to some short response. So alpha particles are stable decay products of many nuclear disintegrations. An alpha particle consists of 2 protons and 2 neutrons and has a mass of 6.644 times 10 to the negative 27 kilogram. When the individual masses of 2 protons and 2 neutrons are added, the sum is 6.695 times 10 to the negative 27 kilogram. The difference between the mass of an alpha particle and the total mass of its 4 individual component particles is called the mass defect. So, number 1, determine the mass defect in kilograms when 2 protons and 2 neutrons combine to form an alpha particle. In this question, mass defect is the missing mass between the alpha particle and the individual protons and neutrons which make the alpha particle. So to find the mass defect, we just need to subtract the total mass of the protons and neutrons by the mass of the alpha particle. So the individual masses of the protons and neutrons added is 6.695. So 6.695 times 10 to the negative 27 kilogram minus the alpha particle is 6.644. So 6.644 times 10 to the negative 27 kilogram. And the mass defect is going to be 5.1 times 10 to the negative 29 kilogram. Number 2, calculate the total amount of energy in joules that would result from the complete conversion of this mass defect to energy. So a conversion from mass to energy should ring a bell because this is just going to be the equation E equals mc squared, and we just plug in to solve for energy. So mass, which we just found, 5.1 times 10 to the negative 29 kilogram, times C, which is 3 times 10 to the 8th meters per second, squared is going to equal 4.59 times 10 to the negative 12th joules. And that is going to be our conversion. Number 3, determine the total amount of energy that would result from the complete conversion of this mass defect to energy in mega electron volts. Okay, so now we need to take the answer, which we just solved for in question 2, and convert it into mega electron volts. So our reference table gives us everything we need. In the reference table, it tells us that 1 EV is equal to, it's equal to 1.6 times 10 to the negative 19th joules. So to turn our energy from joules into EV, we just need to divide the answer that we just got, 4.59 times 10 to the negative 12 joules, by this value, 1.6 times 10 to the negative 19th joules. Because now we're going to get 28687,500 EV, right? And then we just convert that into mega electron volts. So on the reference table, it tells us that mega means 10 to the 6. So we just need to divide this number by 10 to the 6 in order to get the energy in mega electron volts. I'm kind of like running out of space, but basically you're going to get an answer of 28.7 mega EV. Number 4, what fundamental interaction is primarily responsible for holding protons and neutrons together in an alpha particle? So this question is super easy. Remember that protons and neutrons are binded together by strong nuclear force. That's it. Strong nuclear force. And that's your final answer. Now on to our next short response question. So number 1, determine the amount of energy in electron volts that must be absorbed by a hydrogen atom to excite the atom from the n equals 1 energy level directly to the n equals 4 energy level. So this question is also fairly easy. We just need to look on the reference table for the hydrogen energy levels. So at n equals 1, the energy is negative 13.6 EV. And at n equals 4, the energy level is negative 0.85 EV. So now to find the amount of energy needed to be absorbed, we just need to use the equation energy of a photon equals initial energy minus final energy. And just plug in. So it goes from n equals 1 to n equals 4. So our initial is negative 13.6. EV minus negative 0.85 EV, and that's going to equal 12.75 EV. Number 2, determine the sign and magnitude of the net charge in coulombs of a particle that has a core composition of BBB. So once again, look at the reference table to find the value of B. So B is negative 1 over 3E. So BBB is just that, negative 1 over 3e times 3. So that's going to equal negative 3 over 3e, or just negative 1e, which is 1 electron, right? Negative 1 electron. So it asks us to answer the question in coulombs, and if you remember, an electron is an elementary particle, so all we need to do is look at the reference table and find the value of an elementary particle, which is 1.6 times 10 to the negative 19th coulomb, but remember, negative here, so there's going to be a negative here as well. So it's going to be our answer. Number 3. What type of electromagnetic radiation would contain photons each having an energy of 2.65 times 10 to the negative 20 joule? So we're given energy and we need to find the type of electromagnetic radiation contained in these photons. So electromagnetic radiation should hint you towards the electromagnetic spectrum. So we pretty much just need to figure out the frequency of the photons to understand what type of radiation it is. Since we have energy and we need to find frequency, we can just use the equation E photon equals HF and then plug in to solve. So 2.65 times 10 to the negative 20 joule is equal to H, 6.63 times 10 to the negative 4, 34, J times S, times frequency. So frequency is going to equal 4 times 10 to the 13th. And when you look at your reference table and you look at the electromagnetic spectrum, you'll see that this lies in infrared radiation. So the answer is going to be infrared. Okay, so that's going to be our last question for today. Thank you guys for watching the video, and I hope it helps you.